Okay, good afternoon. My name is Neil Mackin. I work for AWS in the public sector team, and I've got a role helping understand how businesses can actually drive value out of their data using techniques such as AI and machine learning. I've spent quite a bit of time doing that, and I'd like to share some thinking with you. And it's fascinating. I can't actually see anybody apart from the front row of these lines. If those of you who've been to the Loft before, is that what everybody says when they get up on the stage and suddenly realise they can't see anybody? So, assuming you're there beyond the front row, let's dive in. And in terms of market adoption around AI and machine learning, there is a phenomenal amount of hype and buzz and excitement. And quite genuinely, I feel really excited now about this. These statistics, Gartner saying that almost every new software product will have AI and ML within it. At the bottom, the market growing massively. CIOs investing in this more than other things in the top 5 of their investments. And even from a couple of years ago, and I think if we looked at more recent data, it would be even more astronomical, the rate of growth of revenue from AI and AI-related services is growing hugely. I do, however, have a little bit of a long view of this, in that it was in the late 1980s, early 90s that I was doing a PhD in AI. And so over the sort of 3 decades, I actually worked on an AI project that came to fruition, that produced a product that was then sold, and I went and sold it into the market, helping in the health sector, helping people make particular decisions around dentistry. And it's fascinating to think, how has the world changed from 3 decades ago to now? And in some ways it has changed phenomenally. We've got new techniques and new approaches, particularly around deep learning, exploiting vast amounts of data, which we never did have back then. And the research that I did took about 2 to 3 years of manual hard graft, actually, to try to understand how a human expert, made decisions, and then to craft a way of making a computer algorithm emulate that, and combining within that fuzzy logic and inference and a complex set of rules that predicted growth. To do that today would be a different challenge, and perhaps an easier challenge. But it's also interesting to think back, how far have things like the work I worked on actually made a difference, and what were the barriers to adoption? And I'm going to pick on a few of those as we go through. But by way of sort of a gentle intro, AI and machine learning use cases are pretty much all over. Looking right across, kind of indexing content for video and media. It just occurs to me I'm actually being videoed, so my words could well be being transcribed from that video stream, and somebody creating an index of all the things that Neil talked about, the key themes Neil talked about, and making that searchable. Thinking through healthcare, life sciences, as I said 30 years ago, I was doing something in that realm. There's a lot more interesting stuff happening now, and it's happening more quickly, and it's being productionized and made operational more effectively. The realm of finance and spotting fraudulent patterns, identifying where transactions are unusual and what we could do about those, right through to the kind of customer experience of trying to automate and enrich the engagement between organisations, entities, businesses, companies, through to ourselves, and making that a more natural interface all the time and a more effective interface. I'm trying to make that interface smarter. So there's a really wide range of impacts. But there are some fairly difficult problems. Where does it work well? Well, it works well in certain key use cases. If you're handling complicated interactions, if you're looking for things which are difficult, I mean, if you could actually code with a few simple rules, the sort of logic of what a decision ought to be, you don't need to use machine learning to do it, you need to use a basic script to do it. But if actually the complexity is such that you can't easily code it, then more complicated techniques, neural nets and so on, were really good. If actually you want to scale it up and you want to do something at a massive scale, so not just at a small scale, but actually on every interaction, So say fraud, for example, where you've got fraud specialists looking at the cases they think are most relevant, but sampling, or just picking out certain ones. Wouldn't it be nice to run all the cases through a fraud screen? So that kind of scaling it up, automating it. Where you want to specialise for every individual to actually tailor the interaction so that your experience differs from my experience, and that happens right across the board. I mean, at the moment it happens to a degree in telcos where we ring up and ask for a new package and they think, well, how valuable a customer is Neil really? Do I want to make him a good deal? And they automate a lot of that reasoning, they predict my future value, they work out their current inventory of offers, and they work out the best tailored offer to me. Wouldn't it be nice if that happened in other worlds as well? You know, I often think about social care. And if my mum was to ring up her local government authority and actually go, I've got a problem moving some rubbish out today, could you help me? Well, I'd quite like them to help her in a different way than they do that if they help me. If I was to ring up and inquire about something like that, I hope they'd just direct me to the website and tell me to self-serve. But maybe an elderly person living on their own, as they know, with whom they've had no contact before, maybe that's a time to actually think, are there other things that we could do to help look after you? Are there other services we might want to check on? Would it be appropriate to maybe come round and help you with that problem, but check on a few other things while we're there, and tailor that interaction and get that guidance? Real time. If we want to actually interact in real time, perhaps through the web, through interaction points, you can't scale up human thinking that quickly. We need to automate it. So these are the kind of core problems in many different areas. Why is it not happening at greater speed? Well, there are some challenges, one of which is actually the expertise you need to do it. The number of people who are actually graduating with PhDs in machine learning and AI is too few for the market demand. And the kind of realms of expertise you need from data science, very few data scientists focus purely on the machine learning. It's a much broader challenge of pulling together the different sets of data you need. And in fact, it's interesting that if you focus on trying to solve the machine learning problem, you quickly realise that that grows into, well, how do I actually gather all the data I need and do the engineering to pull it together? How do I actually worry about the compute, the power of the computing that I need to do that as well? And then, having built a model, how do I actually then deploy it and integrate it with the rest of the IT world? So there's quite a complexity there. There are key kind of questions. Do you hire and build up your own capability, or do you outsource and let somebody else bring their expertise around machine learning to build models for you? The latter is difficult and fraught with problems in that you're in essence letting some of your strategic decision-making capability be controlled outside of your domain. So I would be wary of that. But in building in your own capability is also difficult because it's expensive to hire and retain in this area. I do have good news, however, don't worry. I'll get to better news soon. Scale. Some of the new techniques actually require vast amounts of data, and some of the new techniques require vast amounts of computational power to crunch through that data, which in turn starts to mean you've got a big data management problem on your hands, and you've got a big compute management problem on your hand. Looking after all that kind of inference, all that computing infrastructure can be quite hard and quite challenging. When you do this in production, you also start to get interesting problems of actually how do I keep it all secure? How do I think about the security implications, the encryption implications, the data transfer implications, and that wider context of scaling up from something that was relatively simple, perhaps using a R notebook on my laptop, through to actually doing this at scale for an enterprise. Different problem to scale up. And maybe one of the most interesting problems is actually choosing the right problem to work on. In that machine learning is extremely good at some things. And often we throw it at the wrong kind of problem. So I'm focused very much on helping organisations identify the business problems they've got that are amenable to solutions with these kind of techniques and approaches. And you kind of combine together the art of the possible and the art of the practical. And I frequently will challenge people back to go, if we were to do this, how would you drive value from it? Suppose I make a black box magic AI ML predictor decision maker thing for you. What do you have to do in the rest of your enterprise for that to be valuable to you? Is that the case you've got to change CRM systems? Is it the case you've got to change your marketing approach? Is it the case you've got to actually change the way your organisation works and the way your people work, the way your customer agents work? Simplistic example, if we use AI to help answer some of the questions that contact centres frequently get, and we can do that, we frequently do that, and examples in the UK where people have moved about 40% of their contact centre workload to sort of AI-based chatbots. That actually means you've got two opportunities with the rest of your, with the staffing that you had. You can either upskill them to deal with, on average, a more complicated workload. You've taken all the easy stuff and moved it elsewhere. So you have to upskill your staff to get to work on the complex and the hard. Or you've got the organisational design challenge of reducing the size of that team down in order to realise the saving. But without actually driving that value out, without having the ability to actually execute on that, you might well question why bother with the ML. Why bother doing it? It needs to be derived towards an application that actually releases value. I wanted to explore this really through a use case. And some years ago, I was working in the publishing industry, which is a great place to work. If anybody works in publishing, I loved the kind of culture of publishing. It's really quite creative, but also really quite numbers driven. So the particular publisher in question I worked for had a number of print titles, had a lot of online real estate websites, a lot of online forums, a lot of email lists, and their key question that the chief from the C-suite, the chief exec level, was, how do we actually increase revenue? We've got a revenue problem, we want to increase it. And in discussions with the kind of senior leadership, that could be netted down to start to go, well, we think we've got an opportunity if we increase the ad impression revenue. So if we get more money from the ads that we're serving, in our emails, on our website, on our estate. As you then unpick that down, and that's level, the most salient opportunity is actually to do that from your existing subscribers, those who are buying your magazines or subscribing onto your online estate, to get them to consume more ads, and to consume more ads which they actually want to consume. So we can't just spam them with any ad, but actually we'd like to try to tailor the ads that we're presenting to be appropriate to the content that they're reading, and to get them to read more of that content. So, netting that down into the business problem at the bottom, we've got a number of interesting tasks. We would like, if we could, to start to categorise all the content on our estate, all the different articles. What type of article is it? What sort of person would read it? We'd like to try to see the associationships between those articles. And we'd like to try to understand the subscribers that we've got and build specific and key different profiles that help us match them. And then think through the matching routine at the end. How would we actually, for a particular kind of people, find the right kind of ad to display at the right kind of time? So turning that into how we might approach that with machine learning technology and using the AWS capabilities, we would think in terms of the articles, looking at the articles and screaming through the articles to actually transcribe them, if they're in a foreign language, to use comprehend, to explore what's within them, to start looking at the topics they're about, what are the key entities, what are the key themes, to get a rich understanding of all of the different articles that we've got in a standardised and searchable way. And then use SageMaker to start to build models of the subscribers, perhaps segmentation and clustering approaches, and then start to build a matching algorithm between the two, which starts to give us a series of data science and machine learning tools that we can deploy to actually link these two together and start to tackle what was originally a fairly high-level problem of increased revenue, please. What's interesting, though, is to tackle all the problems in a very KPI-driven way. How will I measure that I'm successful? So, if we think in terms of what are the measures, we've got site traffic volume, we've got click-through rate, so how often people actually click through into content, and we've got the revenue we can get per click-through. And we can actually look at each of these and start to go, let's think about what the current volumes, current KPIs are, and let's maybe assume we could get a 10% uplift in each, which isn't actually very ambitious, really, for something where you've never applied machine learning before. And even getting a 10% uplift in each, so going from sort of 20 cents to 22 cents on the click-through rates, going 3%, 3.3%, 20 cents to 22 cents on the revenue. These are quite small increases, but overall we start to get a 33% increase in the overall revenue from that, if we can deploy it in all these different places and actually start to combine that effect together. So I guess the message I'm trying to drive home through this example is it's really important to actually think through how would I take any machine learning I've done, deploy it into a production environment, integrate it with the other systems that I'm already working with, and how would I measure its success, its effectiveness, and actually track that value and realise that value. And there ought to be a golden thread of value all the way through the project. Starting off with the C-suite going, we want to drive value right the way down. So Amazon has actually got a remarkable heritage in the machine learning space, been investing in it since the 90s, and have actually deployed in a number of different areas that I just wanted to touch on. So personal recommendations, fulfillment. I've got a few slides just to bring these to life. So fulfillment and logistics. It's interesting, working for Amazon, you actually get compared with a lot of the other online retailers or kind of .com businesses, but there's a really interesting difference. It's that Amazon is fundamentally about bits and boxes. And that fulfillment side of it, that actually moving huge amounts of infrastructure around, is a very hard challenge. So managing, I'm expecting something to happen on this slide, it's not, is it? Sorry, so these are images of robots which actually move inventory around in our automated warehouses. So rather than people necessarily walking up and down the aisles to find stock, the order is created and then the stock is moved on shelves to the pickers, which is great. Start to decompose that. You've got a robot with with visual imaging to understand what it's about to bump into and avoid it, and you've got an optimization challenge of minimising the movement of stock and the correct placement of everything. So it's a massive, hard problem, which we've got a team of machine learning and AI experts in Cambridge focused on optimising the physical route of things through our supply chain, as well as teams in Seattle focused on developing these robots themselves to move stuff around. Search and discovery. Search and discovery is incredibly important, and if, like me, you've ever used the Amazon website, you will undoubtedly remember the bit at the bottom that says, well, people like you might be interested in things like this. That actually drives a phenomenal amount of revenue for us. And that recommendation is hugely important to us. And it's something that over the years we've improved and improved and improved the algorithms that go into that. New products. Amazon is fascinating at developing and innovating and creating new products. So some years ago, a number of people in the natural language and speech recognition world, leading researchers, were gathered together and challenged with the far-field speech recognition problem. In other words, if I'm stood in the kitchen and I've got a device, a microphone over there, could it understand me above all the other hubbub in this space? Which is a actually phenomenally difficult problem. And they initially approached this with skepticism as to whether it's possible. But it did, after a lot of research, get to the point where we could release the Amazon Echo and the Echo Show, which I've got a demonstration of, a picture of here, and to actually bring a fascinating new way of interacting with computers into people's very living room, very kitchen, very world. Another far-sighted, interesting project we worked on was Amazon Go. And this took about 4 years. Amazon Go is a city centre supermarket with no checkouts whatsoever. So you go in, you scan your way in with a barcode, a bit like you all scanned your way into this session. Then you put your phone away and you pick things off the shelf, put them in your pocket, put them in your bag, put them wherever you want, and walk out. and it bills you correctly for what you've taken. It's a genuinely phenomenal experience, and I went in our store in Seattle, then came back to London and went to one of our high street stores, and it was such a drag having to use the checkout. It really was. Standing there, and you got to self-serve at the checkouts in London. I don't know why, but yeah, I'm doing it for them. Why? But the research behind this, it's got LiDAR sensors in the ceiling, it's got infrared sensors in the ceiling, it's got video sensors in the ceiling, and it took 4 years to make it work properly. I mean, at one stage, we thought we'd got it working. We got a load of Amazon staff in to come and test it, and we detected that actually it worked really well if you were right-handed. But left-handed people, they're difficult, and the algorithms didn't spot them. So we went back, trained it up with more images of people who are left-handed taking things off the shelves, and got it to work. And then we tried it again, and discovered that children are different in shops. They don't behave like adults. And so we had to train it up with that. And eventually we got it to a level of our confidence that it was accurate and correct and working, that we could release it as a commercial product. It's a phenomenal innovation. It's also an interesting example of the preparedness to drive innovation and to take significant risks and to push the boundaries and to see what will happen. And there's something about risk-taking and exploration and preparedness to fail that is really key in the machine learning AI space. You are exploring something, it hasn't been done before, you can't accurately predict it is going to be doable. You've got to explore it and see, will it work? So, AWS is bringing AI and machine learning capabilities for others to use. We're not just keeping it to ourselves and using it for ourselves. What are we actually trying to solve for? And there's probably 3 broad themes that we're trying to solve for. One is that data scientists, machine learning experts, actually spend most of their life not doing the algorithm building piece. They spend most of their life faffing about getting data into a place they can use it, and then preparing it, and worrying about creating the right compute space. Another one is, how do we actually drive it through into value? How do we actually drive it to value by helping people use more and more of their data, rather than a little bit that you can easily manage, so bringing the data together. And how do we embed it into the business? Right at the bottom, this is calling out that most of the models that ever get built don't actually get used. And as I highlighted earlier, if you don't put it into production, you don't realise business value. It's a fascinating data science experiment, great fun, but it doesn't actually pay the mortgage. So driving it into production and embedding it into the fabric. Why is this hard? So machine learning is extremely hard. It is very tricky indeed. Working around this circle, right up at the top, you've got the how do I actually source all the relevant data that I'm going to want to use. And data can be in many different areas, in many different forms. It could be unstructured text, it could be videos, it could be nice granular data in structured databases, it could be massive streams of data flowing through. How do I manage the many different types of data? How do I gather that, clean it, format it, prepare it and transform it, or within it start to pull out the features that might be salient to the problem I'm actually dealing with. Going back to that publishing example I talked about earlier, we spent a lot of time thinking about different subscribers, different types of users. Does it matter when they're working with it? We've got a stream of clickstream coming through here, 24 hours a day, every click they do on the website. If we pull it apart and start going, they only ever seem to do it in the early evening when they've just got home from work. Or they only ever seem to do it in the morning, or there's a big bulge at lunchtime, or actually they're doing it all day long. You've got different patterns of behaviour there. If you've got the same account being logged into from different IP addresses, that gives you a different kind of behaviour, different type of person. So pulling out these different salient features, handcrafting the features you need, and then getting onto the actual model building bit, creating and choosing the right model, using the right algorithms, and then tuning and fine-tuning all the parameters and hyperparameters within that model. It takes a long time. And then I've got a model that works. I've somehow now got to actually make it deployable, sit it into the IT world, get other people to flow data through it, and get them to integrate it into their systems. And that's quite tricky and hard. So we have solutions across this space in 3 layers. Right down at the bottom, we work with a number of frameworks and interfaces that allow machine learning experts to use and handcraft their own models. And we enable them to use a range of different frameworks on the bottom right-hand side, so Keras, TensorFlow from Google. Most actual use of TensorFlow happens on AWS in the cloud, about 80% of it, in fact. So a range of different low-level deep learning frameworks, and we provide high levels of compute power with specialist infrastructure, so NVIDIA chips, P3s with lots of GPUs, which you can rent by the hour to use instead of investing in your own. So it creates a fast and flexible framework that you can use very quickly if you are familiar with handcrafting your own code. You can get started really quickly using an AWS machine image for deep learning, already optimized to work on that kind of processor, so you don't have to worry about that, already loaded with all the different libraries that you need. So instead of downloading Anaconda or getting CUDA to work and then downloading the latest versions of all the Python kit that you need, it's all up and ready to roll. And also we provide all of that at no extra charge over and above the compute power of the EC2 instance itself. So it's a great environment. We also invest at this deep learning framework level very heavily in one of the deep learning frameworks, MXNet, where we've got teams of people in, I think, San Diego and Palo Alto, I must visit them, who are focused on actually pushing the boundaries of that particular framework, contributing a lot of code to MXNet. And if you've not looked at it and you are in that deep learning framework world, I would recommend having a look. It is highly optimized and highly performant and quite portable. So, no good talk would be free without a little bit of code. So I was going to mention Gluon, which is a framework library within MXNet that allows you to create your own deep learning models in a really simple way to understand. And it also allows you to change those models. So this is probably best with one of 2 bits of code in my presentation. So the AlexNet is one of the famous kind of PhD research papers that was focused on creating a convolution neural network for image recognition, which worked incredibly well. And I think it's about 2012 that it was originally published. But after that, the particular paper's been cited about 25,000 times of other people going, looking at this work, this is what we're doing. And on the top right is a kind of visual representation of that net with various layers of different kinds coming together. And on the left-hand side is the actual code you need to write it out in Gluon. So as you can see, you can put convolution layers and pooling layers working all the way through to fully connected layers which flatten it together at the end. And it's a relatively quick and easy way of describing that net. Gluon also allows you to have full visibility into what's happening as you train it. More than that, you can actually, if you want to, change the structure of the net partway through the training. So you could add layers and take layers away. So it's dynamic in the sense that the structure of your deep learning model can change at your control as you go, and you've got full traceability and ability to debug it right down to the code level. So a really phenomenal capability. I mentioned earlier, however, that the availability of PhD level data scientists who are actually going to code and handcraft their own deep learning algorithms with this bottom layer are quite few and far between. If you've got them, look after them, don't lose them, protect them, keep them safe. But if you haven't, how do you get into this world? And there's been over the decades many attempts to make machine learning, deep learning, data mining available to the masses. We used to call it data mining years ago in a different kind of flavour. And a number of these attempts have kind of created a push-button approach or a graph drawing approach where you'd create a few nodes, link them together, and some computation would happen and some model would be created. But nobody would really understand. You'd have a way of making a prediction, but you didn't know if it was right or not. So tackling this, bringing it to the masses thing is still a problem. And the approach that AWS has brought out is a product called SageMaker. And it's looking at tackling these kind of blockers and barriers along the way. So as I've said earlier, for most machine learning problems, getting hold of the data, managing the data is quite hard. Working out which algorithm to use and getting the algorithm to work in your compute environment is quite hard. Creating that compute environment to actually run it is quite hard. And basically, I didn't go into wanting to be a data scientist in order to become a compute infrastructure engineer, managing clusters. I don't want to do that. That's not my job. I want to focus on the algorithms. Working out how to actually get the very best out of that algorithm by fine-tuning the model with all the hyperparameters. That's quite cumbersome and quite time-consuming. Then deploying it, trying to find a way of getting production data to flow through my model is quite hard, and managing its decay over time to know when I need to rebuild it. So tackling each of those, we've created SageMaker, which later this month will have its first birthday and probably develop massively in its capability at the announcements that will happen at reInvent later in November. It's our kind of big release of new products, so watch this space. Everything I'm about to say to SageMaker, I'm probably going to have to revise the slides to make it better in a month's time. But SageMaker allows you, in a very easy way, to build machine learning algorithms. It gives you a notebook interface using Jupyter notebooks, so you can write your own code, your Python, your R, any other standard scripts in an environment that machine learning people are very, very familiar with. And then you can use a number of, I think 14 at the moment, highly tuned, performant, built-in algorithms, which you can call with a single line of code to set up the parameters and call them. And then it will, for you, go off and train the model. It will actually, the different algorithms. The algorithms at the moment cover the broad range of capabilities you'd want, so supervised and unsupervised, some for unstructured text, like latent to recently allocation, some for the kind of classic clustering problems, like k-means, some of the standard kind of XGBoost algorithms for random forests, and we've also got our own algorithms that we've created in here, random cut forests, for anomaly detection over time. And these have all been optimized to work in this environment. So with one click, I can actually drive the training of that model. And what it does is it takes the data that I've specified, which I could have sourced from any of the AWS environments, so S3 data, object storage, data sitting in structured databases, RDS or Redshift. In fact, I can hook it up into Athena and actually pull data from a number of different sources together through a kind of an ETL script and actually fire that into it. So if you've got your data in an AWS world, it's easy to draw it together, aggregate it, integrate it, and flow it into my Jupyter notebook to manage my data, and then put it into a machine learning algorithm to go, click, off you go. It's also, having built the model once, you scratch your head and go, if I tweaked a few of these parameters, if I had a few more nodes in my layers, if I had a few more trees, if I had my learning rate a little bit different, if I used a different algorithm for my learning rate, what would happen? And so we've created hyperparameter optimization, which basically allows you to automate the tuning of the model by trying a vast number of different sets of parameters and have it work out the best approach by actually using the machine learning approach on top of the machine learning. So it automates the search for the best set of models, best set of parameters to run the model with. So maybe with my second bit of code I can bring that little bit to life. So supposing I've got an estimator here, and it's using the MXNet library underneath, and it's using a particular instance type here, and setting up the configuration, setting up that I actually want to do this particular type of learning job, and then I can specify a number of the parameters. So different kinds of optimizers to use. There's the search, the learning rate optimization bit, so an Adams search or a gradient descent approach. Different learning rates to use, anything between 0.01 and 0.2, and how many epochs to run, any integer value between 10 and 50. And it automatically searches out a whole heap of different combinations of these and finds the best possible one for you. So it takes away the pain of tuning your models. We then actually have the problem of deploying it. And the fascinating thing that SageMaker does is having created that environment, when you click the one button to go, please train it, it will fire up the necessary instance, necessary containers, load the data, run the model, tune the model, shut down those containers. You don't pay any more after it's trained. You can then deploy it in a similar way. You could do with a deployment approach of creating an endpoint that creates a container and fires the records through the container on demand. So in essence, it creates an API for people to access your model, to store records flowing through that model, and it manages the whole compute infrastructure around that for you. And you could wrap that up in a fully managed way that becomes auto-scaling. So if you want to put scaling groups on top of those containers, you don't have to worry about the volume's growth or shrinkage of how that model's being used. It can very quickly be integrated into the rest of your IT estate to deploy those models. We've also explored how do we physically put machine learning capability into the hands of developers in a very, very literal way, and created a deep lens which combines together a small amount of compute capability with a high definition video camera and the ability to integrate this with SageMaker so that you can build your models in SageMaker and then deploy them through Greengrass down onto the device itself. So if you ever get bored at work and want to do more machine learning at home, you could set this up to actually start taking pictures of the cars coming up your drive, recognising the number plate through image recognition, going, actually, that's my car coming up the drive, I'll open the garage door for you to come straight in. Or you could put image recognition in your lounge and have the video camera pointing at your sofa and telling you every time a dog sits on your sofa, that kind of thing. You could actually bring machine learning to home. So in a way, it's creating a device to allow people to actually take compute machine learning capabilities and deploy them right at the edge. It's a great fun device to look at and play with. Let me give a couple of examples beyond the kind of playing with it level, but one of our customers, Intuit, who, if like myself, you have to return your finances to the authority to make sure you've been paying the right amount of tax, then they've got a great product for managing all my financial affairs, uploading them, and they've created the capability with SageMaker to actually automatically analyse every submission to go, are there telltale signs of error or theft, identity theft in particular, in the way this has been submitted? Can we actually start to spot problems with the uploads of data around people's finances, a very critical part, to actually spot errors that are going on there at filing time? Another example of GE Health are looking at using SageMaker in a number of different application areas. So thinking in terms of predictive health and diagnostic health, some examples like taking images of, say, retina scans and identifying within that retina scan, can we actually see the decay that you'd see in a retina that's associated with decay associated with diabetic conditions, and is this something we could intervene with early? Typically that's the sort of thing you'd have to get an expert to take a retina scan and stare at it for a long time, but you can use image recognition to actually focus right in on that and then start using machine learning models to spot, yeah, these are the ones which are a problem with, you should look at these. So I've covered the lowest level, the kind of frameworks for the machine learning gurus, the middle level, where people who can script, people could integrate data together, could actually access the power of this machine learning capability. We've also got the top level, which we call AI services, which are very much aimed at developers to actually take the power of the capability of pre-built models and deploy those. Across this space, we've got a number of different tools and capabilities that people can use. So Amazon Recognition is a service that, with an API call, a developer could get access to putting in an image and have it automatically detect, use facial recognition or object detection or celebrity recognition, or identify text within images, all at the single call of an API line. So this has been used by one of our customers, Sky, to actually take the feed from the royal wedding last year and recognise who all the celebrities were walking in and out of the church. And so it could call up little facts about them in real time. Which I think is quite neat, really. I did. It's quite impressive, particularly when some of the celebrities, I don't know who they are, and some of them even look alike because they all wear the same sort of uniform. So, we can also focus it with a sports challenge of actually tracking individual players running around on a soccer pitch and seeing what path they were following across that path, across the field, and following their particular engagement with that game. And these are fun, and these are entertainment. And I suppose if you were mad on sports, you'd criticise me for being a little bit flippant there. But I get a little bit more excited by use cases like Marinus Analytics, who are using it to actually track human trafficking. Can we see certain faces passing through certain locations where we think they're actually likely to be being trafficked against their will? And certain airports in the United States, I think Atlanta in particular, is kind of known to be one of the key hubs through which humans are moved against their will. And can we identify them, and can we track them, and can we pick that up early? Another similar use case is looking at imagery around child pornography. Could we track from the dark web images which actually are of a child that is known to be involved? And could we see how they flow and how they move, how they attract? And within that, there's obviously the potential to make a significant difference in one of the horrible, nasty parts of society, the criminal activity around that. But there's also the benefit that those officers, the agency officers involved, the police officers involved, don't get harmed by having to look at such hideous images hour after hour, day after day, which has a profound dehumanising effect on the human spirit of having to do that for your job. So to get the computer to take some of that load and some of that burden away, so that they're not having to sift through image after image, I think is a fantastic change. We have speech and language capabilities, so we have a number of products in this range. So Transcribe can take an audio stream and convert it into a written stream of the words that are being used. In fact, it can do that with multiple speakers at once. We could take the audio stream from this talk this afternoon and convert it into the words they actually used and compare them with the words I intended to use and see the differences. Translate between a number of language pairs. I think it's about 120 language pairs we can translate between at the moment. Poly, could we turn the written word into very, very realistic human-like speech? In fact, some of the training that we provide for people uses that very technique, and I sometimes wonder, was this automatically generated or was this a human? For some of the voices, I can't tell. Comprehend allows you to analyse what's within the written word, and Lex allows you to create conversational flows and interfaces. So let's look at a little bit more detail in some of those. So Transcribe, I've kind of summarised, but we've got multiple languages. It can take an audio stream and actually turn it into a properly structured, well-punctuated, well-written set of prose that was used in that, as well as time-stamping it. And if you're using say, call centres, you can actually say, well, the agent said these words, and the caller said these words, and these are how they kind of came together. So you can identify multiple callers within an audio stream, either because it's recognising the different voices or because you fed them in on different channels, both ways around. An example of this, actually quite close to this scenario, is a training example where Echo 360 are helping universities by videoing the feeds of their lecturers and then creating searchable content where what they were talking about, you can actually search for that particular bit of the lecture. Around about the 37th minute, they said something about the particular thing you wanted to search on, so you could dive straight in and actually allow you to do that. So it makes video content much more useful and more easy to consume. Translate pretty much does what you might imagine, takes one set of language and translates it to another language. Does have automatic language detection, and it's relatively low cost. Poly converts from the written word into the spoken word. And and you can control it in very fine ways. But I get excited when we start to use it in different ways. So we can start to actually give voice notifications and start to bring interfaces to life where you could talk to it and it could talk back to you. It's a much more natural approach, and I think that actually opens up the realm of the internet, the realm of computing, to audiences that wouldn't have naturally gone there. We're seeing a lot of that with older people engaging with councils and authorities, as well as those in a working environment where it's difficult to do that. And perhaps if you're working in the street and you've got lots of equipment, perhaps you're working for a utility provider, and you want to report something that you're seeing, well, why not pick up your phone? It knows where you are, it knows who you are, it knows when it is, and talk to it and tell it what you want to describe. So over there's a particular pothole we're going to have to come and fix. It'll take about this length of time, and then create the task automatically. So giving a better interface for people to use. I can also get excited when we start using this around accessibility. There's a lovely pilot in the urban transport of London for one of the underground stations, where for blind people, we've created a series of beacons in the ceiling through the underground station, through the metro as it were. And then they've got a little audio that picks up where they are and describes to them. So you're nearing an edge, you've got 2 feet before the edge, then there's a step down. Now you've got 13 paces to go before you need to get the rail on the right. And they can actually guide them right from the street all the way down to the platform without them needing assistance. So it starts to make the world easier for them to use. There is also language training. So Duolingo have extensively used Amazon Polly as one of their approaches to help people learn new languages, speaking out the new language for them. Amazon Comprehend is a capability to take large amounts of unstructured data and apply machine learning algorithms to start to understand the content. So if you've got a library of documents, if you've got vast numbers of emails from customers, if you've got loads of contracts from lawyers, and you actually want to understand which ones relate to which, and if I was going to alter this document, which are all the other documents I might wish to read, or if you just want to make a searchable index that goes beyond the kind of simple syntactic these words were seen, but starts to talk about the themes that are being used and how they associate with each other, then Comprehend does all that for you. And Amazon Lex is a capability of creating conversational interfaces, so you can start to actually describe the steps in a conversation and enable those over a number of different mechanisms. So building together kind of a contact center bot to actually chat in real time, informational bots just to explain things to people, enterprise productivity bots who walk into a meeting room and go, my meeting is now starting, and it will record the facts and track all that and set things up for you. What's exciting is that you can start to connect these into back-end systems and pull data together. So as a local authority about 30 miles away from where I live, where old people can now chat through a Lex based device to go, could you tell me how much I owe on my bill? And it interfaces into the systems and comes back and tells them. And again, this Lex based interface for somebody who had was deaf and unable to hear a contact centre agent, they actually found they could use the chat interface that used the same Lex rules as would have done if you'd used voice, but they could use chat online to actually achieve what their interaction. And they were thrilled because they didn't need to get somebody to help them to do it. They were empowered and enabled to get on with their own life themselves. So, in closing, I've a few kind of contextual thoughts. And it's kind of good, I guess, maybe after 30 years of working in related fields to AI and machine learning, to ask, well, where are we now? And where are we going? And I think it's fair to say we have actually moved a phenomenally long way on the technical journey. The releases that have happened in the last 5 years or so around new algorithms, around deep learning in particular, have opened up capabilities around pattern and image and voice and natural language understanding, which were dreamt of 30 years ago, but not realised. And it's interesting they've done it in a way by tackling vast volumes of data and building unfeasibly deep neural networks. which is completely undreamt of 30 years ago when we were grappling with could we try to get the computer to create an understanding, a semantic understanding of the words in a sentence so we could translate it, as opposed to taking the profoundly effective approach that has been taken with deep learning, with very, very deep convolution neural networks trained off vast volumes of data at huge computational expense. So technically we've come a phenomenally long way, partly because of the cloud giving us that compute infrastructure, partly because of the GPU revolution with chips and giving us the compute power, and partly because of some pioneering research in a small area of the machine learning world. It's worth remembering there are a lot of other areas where we still have research breakthroughs to make. And we've currently got a set of tools which solve a significant number of problems, but not all. We're actually relatively light when it comes to having the computer genuinely understand. It has the impression of understanding. It can translate from one language to the other, but it doesn't genuinely comprehend what has been said in the way that you comprehend what I'm saying now. So maybe we'll go somewhere on that journey too. And we've got a technical capability, which I've described with the AWS offering, to actually make this feasible at scale for more and more people in more and more ways. I would, however, say we've actually got a cultural journey to go on as well. And I don't see us making as much progress on this as we need to. And I think this is an area where we need to shift to. So I'll just share a few thoughts on that and go common challenges when you're trying to advocate for machine learning in the workplace, in the enterprise. It'd be interesting if anybody else actually gets fed back with this kind of, well, I've been reading an article at the weekend, and or I watched that film. Isn't artificial general intelligence here? Aren't computers genuinely aware and understanding, and aren't they about to take over all the humans anyway and do us out of existence? The kind of sci-fi bunker. Which is a frustrating problem. I think education is needed. The AI bit of isn't that just a chatbot then? We've got a chatbot on our website. Haven't we done AI? No, you haven't. That idea that AI solves everything, whereas it doesn't. It solves a particular, profoundly useful subset of our problems. I've often been given a pile of data and told to go find something interesting, please, Neil. That's very annoying. Try to avoid that. I think you always need to push back and go, well, at least please tell me, what are your business objectives? What are you trying to do? What would good look like? Not just give me some data and I'll show you some fancy charts. And then managing AI projects, and I alluded to this earlier, but there's very few people who are genuinely good at managing data scientists and machine learning people, because it's not like any other project. It's not like a traditional waterfall approach or a traditional agile project where you'll get to an end in a certain length of time. It brings up different challenges and it's much more exploratory in nature. So, a few thoughts of advice for business leaders. First of all, I would say you need to set very strong top-down leadership. You need to be very clear about the ambition and the goals that you're setting and the investment that you're making in the world of data, creating data as something that's key and important in the use and exploitation of that data through machine learning and AI. So set very big goals. Set high challenges. Just as Amazon did with that, dear machine learning, natural language people, try and make a box over there, understand me while I talk over here. That's hard. Or try and open a supermarket with no checkouts. They're big, big goals. Because in striving towards the big goal, we will make interesting breakthroughs and innovations. Set a data strategy. Data is incredibly valuable, but rarely is it actually managed, curated, and treated as an asset within an organisation. It's interesting, we have human resources departments to look after people as resources, our staff. We have asset managers to look after our buildings and our physical infrastructure and tag all our computers as assets. And we have financial directors who look after all the money. We don't have people necessarily at the top table who look after the data, curate the data, and drive the greatest value out of the data for the organisation. We should. We should have a data strategy. We should be understanding what data we have today. We should be asking ourselves, out of all that data, if we're going to use it for machine learning, we're often going to have to label it. We're actually going to create some sort of ground truth that we can learn against. How are we going to do that? How are we going to create the feedback loops? How are we going to keep track of things? And how are we actually going to identify this particular pattern genuinely was correctly labelled in this way? And can we ask ourselves, looking forward in a year or maybe two's time, what data would we wish we'd had? Because you need to start creating it and collecting it now. I'd also say, hire all the people who get data that you can get your fingers on. Hire the data scientists, the machine learning people, and create a culture where they want to work and they will thrive and they will do great things for you. And that creating the culture piece is quite key. I would, of course, suggest you make tools like SageMaker available to all of them, because it will supercharge what they can do. But I also would not put them in a corner. I would say make sure they're close to your business teams. Create a dialogue between the people who you're driving with business challenges to drive your numbers to achieve your enterprise's goal. A really clear dialogue with your data science teams so they work together. And that closing that loop is key. They do, of course, talk completely different languages. They don't understand one another, but trying to get them together, work together is key. So, some advice for machine learning practitioners. I would say learn some sales skills. Because actually, when you're communicating with the rest of the business, they don't understand your language. You need to convert what you can do into what people want. You need to be able to articulate how you will solve the business outcomes of a particular team. And then having done it, you need to present back, I have analysed your data and I recommend you take the following actions. Not show them a load of slides and visualisations and show them coefficients and talk to them in gobbledygook that they don't understand. That's all necessary, but not for selling the original project or the outcome of it. So talking about business objectives. Telling stories with evidence. So we've done this project, we've created this outcome, translated into a story that people can latch onto. That may well be, we've created a number of clusters. Within this cluster there are people who are this kind of age, live in this kind of area, work in this kind of way, and this is their problem, and this is how we could treat them and solve their issues. Making it human. And innovate incrementally. So deliver something quickly and then make it better and better and better, rather than focusing on what's the best possible result we can achieve. It's very tempting in data science to try to do the best possible science, whereas the business just needs something that's a little bit of a percentage better than what it's got today. Reap some value from that and increment. And of course, work incredibly closely with the technical journey and the cultural journey. So getting together with the two sides of the technical and cultural fitting together.